Alright, so this is part 2 to our Terminating Decimals video and lesson that we're trying to teach our students. And I just want to show you different representations on how you're going to show them the tenths, hundredths, and thousandths place right to the decimal. And so we're going to represent 1/10 with a flat. And the reason we do this is this can be looked at as 100. There's 100 little units in here, and so it's our biggest unit block that we have, or base 10 block that we have, and 1/10 is closest to the ones place or to the decimal, so it's our biggest number. Then we're going to use a rod, which is made up of 10 units for our hundredths place, and then for our thousandths place we're going to use a unit because it's our smallest base 10 block, and it's farthest away from the decimal point. And so it's going to be numbers out here, like if you had 0.008, this is a smaller number than if you were to have 0.800. Okay, so as we teach our kids about terminating decimals, we need to also think about what standards we're going to be covering when we are talking about these terminating decimals. And we want, especially when we talk about Theorem 7.1 with prime factorization of the denominator determining if a fraction will terminate. We want students to make sense of the theorem and make sense of this idea of, when we talk about the fraction 7/9 being 0.777 repeating, we want them to make sense of this theorem, and we want them to make sense of why we're using these base 10 blocks and why we're doing the prime factorization of the denominator to learn if a decimal is going to terminate. We want them to persevere. This is a very hard, when I was learning about it, it's a very hard concept to understand, and so persevere through their learning. We want them to construct viable arguments. Why is it going to work? Try to have them explain to their classmates why they think that their pattern is going to work. We want them to model with math. So this is, again, using these base 10 blocks to model their fraction representations. Be precise with their work and look for structure and for patterns using inductive and deductive reasoning. And so finally, we want to talk about misconceptions, common misconceptions when we look at terminating decimals. And like we talked about, we have 7/9. We learned about 7/9 being always, if you have 6/9, that's going to be 0.666 repeating. And we understand that these fractions don't terminate, but then why is a prime factorization of making 1/10, if we do this prime factorization of 2 and 5, why do we have to only have 2 and 5 as primes in our denominator for it to terminate? And so especially when we looked at like the problem, let's see, 3/2 squared times 5 cubed, a common misconception is, well, this is 10 and it's in the denominator, so according to Theorem 7.1, this should work because it is 10, and it says if 10 is in the denominator and we have a set of 2 and 5, then it should terminate. But we have to have kids understand that these have to be pairs, and since there's only 2 here and there's 3 here, these aren't equal, and so you have 1 left over 5, and therefore it makes it to the point where it's not going to terminate. And so these fraction pairs, this is probably one of the biggest misconceptions that students are going to have. So as we look at terminating decimals, we also need to understand how we can represent it and what standards we're going to cover when we are teaching this to our kids.